Hello, welcome to Node Spaghetti. Today we're going to be doing a look at this facial shape key rig. And you can see you can create a very expressive face with just a few different controllers. And sometimes you can make some very silly expressions this way. It can be a lot of fun to play with. We're going to look at how this is done. So over here, I've got a whole bunch of shapes in a hidden collection. If I unhide this, you'll see that there are a bunch of different versions of this character's face. This main rig right here, if we go ahead and move it over, is like a neutral in-between pose for all these different shapes. And when we move the rig controllers, you can see that it essentially turns on the shape that is controlled by the bones. So see how it becomes the frown or the smile based on where I move these mouth corner bones. And if I move them, in, then it becomes the pucker, and if I move them out, it becomes the stretch. And that's why when we move it, we can get this really easy to understand and use motion. You'll also notice that the bones only affect one side of the face, even though the shapes are symmetrical. So that's our goal. We're going to go ahead and add a whole bunch of shape keys to this face using nodes, and in order to understand how to use the nodes to do it, and why we should use nodes to do it, we're going to go ahead and do it the OG way, without any add-ons or special features to benefit us. This is a version of the same character with no rig at all, and it has no shape keys. I've deleted them. So what we're going to do is we're going to add a new shape key by pressing the plus here in the shape keys panel inside of the data tab of the properties panel. Let's select our shape and select our character geometry, and we can go down here and choose join as shapes. Now if we slide this on and off, it will turn the shape key on and off. Very nice. We need it to be two shape keys, one for the left and one for the right though. And in order to do that, we can use vertex groups, which you can see is an option if I have the shape key selected here. I've already gone ahead and created a left and a right vertex group. You'll notice that the left is the character's left, not our left. It's sort of like stage left, right? And same thing with the right. The way I made these vertex groups is first you add a new group, and then press 1 to enter vertex selection mode, Alt, and then select this center ring of vertices. Assign it with a weight of 0.5 to the vertex group, hide the middle, press L to grab what's left, assign it with a weight of 1 to the vertex group, unhide everything with Alt H, enter weight paint mode, and you can see we've got a very exact 50% in the middle, 100% on the side. I like to smooth it out a little bit, so if I go to this weights menu up here and choose smooth, then I can smooth it and I can set up a bunch of iterations. Let's go ahead and turn that on and then choose left and then choose right, and you can see what that does. If we want to make a duplicate of this shape key, we can do a new shape from mix. And what's the big idea? We don't have the vertex group selected, but it's still acting like it's there. What we need to do is we need to either turn off the vertex group, set it to full, and then do a new shape from mix, and now we've got it. Or we need to select the object again, select our character geometry again, and then join the shapes again. That's kind of a bad way to work, but it is what it is. My goal right now is to show the workflow, but also the shortcomings of the old way of doing things. So let's go ahead and set our vertex groups back, right and left. Let's name these .r and .l, and we'll turn them both off. Now we want to make it so that the bone controls the shape key. So let's go ahead and set the shape key all the way on, and let's put the bone there. About how high is the bone? It's about 0.02. That's an easy number to remember. And of course, since we want to move it up and down to turn it on, I only moved it on the z-axis, because right now we don't want left and right or forward and back to do anything. So let's go ahead and select our character again, go to our shape key, add a driver, and open the driver window, and you can see it creates a driver for us. The driver has a type which defaults to scripted expression. It has an expression and it has a variable. Now we need to set the variable or else it won't do anything. So let's set the variable to our face rig, which is called face test, this object right here. Notice that when I have the armature selected, the driver goes away. That's because we have it set to show only selected. Let's turn that off. The bone is called now, of course, you've got a whole bunch of drivers in your scene on other characters or on this character. You can see that it's already turned on. They'll be visible. And if I move it up and down, nothing happens. Turn that off. So I move it forward. That can also be kind of annoying. Fortunately, this is the only driver in the scene, so that's not a problem. That's because it's set to X location. We want to use the up and down, so that's our Z location. And you can see it's still turned on, probably because the expression is set to var plus 1.0. So let's change that to, first of all, I'm going to call the variable A. And now you can see that it's evaluating to a number it's way up here, 2.456. And we have to move it all the way down to the bottom of the scene in order to get it to turn off. See that? That's because right now it's evaluating it in world space, which is located where these axes cross. That's the origin of the world. So if you take a look at where our 3D cursor is right now, you'll see that it is at 2.45, and that's exactly what the driver value is evaluating to at the moment. We want this to be relative to the original location of bone, not to its like overall world space location. So we can set that to local space. And now you can see that the driver is doing something when we move it up and down, but it's not very responsive. And I don't think our animator will be very happy if he has to move the bone all the way up there to make the character smile. The last thing we need to do is make it so that our driver is more responsive. Now, one way that people often do this, they do something like having the expression multiply by 50. And you can see that now this thing that moves left and right moves left and right a lot faster, 50 times faster, in fact. And it works, it's nice, and it's the way people usually do this, but there's really no reason why Blender should have to think about how to multiply these two numbers together. We can just set it to some value or average value, and we can use the curve itself to control this behavior. And in order to understand that, let's talk about what a driver is. In a certain other very popular software, which we don't discuss here very often, this is called a driven key, because what it really is an animation curve where instead of using the timeline to control what the value is, we use the driver variable. And the driver variable is this bone's Z location in local space. So you can see that the expression of the driver moves back and forth when we move the bone up and down. Now, what we want is for the value to be equal to 1 to turn our shape key all the way on when the frame, if you will, is at 0.02. That's the value we decided on earlier. So the way we can do that is we can go over here and make sure we have our driver selected, click on F curve, and then we can select the keyframe that we're interested in, set its frame to the value of the driven object parameter, or the variable, 0.02, where we want it to have this value of 1. And if I set the value to 2, and then go into our shape key and make the maximum 2, you can see it sets it to 2 instead of 1. If I set it back to 1, you can see it sets it to 1, and now if I go higher, it goes higher. We can control the value of the shape key by moving the bone, and our curve is now shaped the right way to make it do this without any expression. By the way, you'll notice when you try to move the curve that it wants to stick to values that are between 1 and 0. Like it tries to stay exactly on the integers. That's not good. If you want to turn that off, you can click this magnet up here, and now you can move it freely. That's annoying. I don't know why it's like that, but it is. Anyhow. Now we've got our driver. We want to make it so that our controller is easier to use. It's a bit annoying that we can move it anywhere, even on the axes that don't do anything. So we can go ahead and just lock the X and the Y if we want to, but it still goes too far on the Z axis. So what I'm going to do instead is I'm going to add a limit location constraint. If we go over to our properties panel and click on bone constraint, add a bone constraint, choose limit location, and let's just turn all of this on. And oh, where'd our bone go? It's down at the root of the scene again because it's set to world space. So let's set that to local space as we did before. And we're going to go ahead and set the maximum Z to our maximum value of 0.02. And now you can see that it stays in the right place. Very nice. But there's one more problem. If we go ahead and open up our move tool, you can see that we have to move the bone a lot before it starts to respond. That's not very nice. And the reason for that is because if we turn off the constraint, the bone snaps up to there. Its actual location is these values right here, and that's its transform property. See, transform. So you just want to turn on effect transform, and then if you try to move it, it will snap into that range, and the control is a lot more responsive. Very nice. The one thing we need to do now is mirror the driver and the shape key. And in order to do that, we can copy the driver and paste the driver. And now both sides are controlled by the same bone. So we need to select the object and go back into the driver editor one more time, select the new driver, mouthsmile.r, and then change the bone to mouthcorner.r. And now it works. And finally, we need to go into edit mode. We need to select this bone because we want to copy its constraint over to that side. And we need to open a context menu and choose symmetrize. I press W, you might right click to get the context menu open. And now we've got both of our controllers. So that took about 10 minutes. I can probably do it in 5 if I'm not explaining it, but that's kind of a lot of time to spend and a lot of clicking around in menus and dealing with different objects. And like, if I want to find out what kind of drivers there are on this character, I've got to go into the driver editor by finding a driver, right clicking on it, and then opening this window. And now I can see that it's applied to something that's called key.007. I don't know what that is. Is that the shape key? Well, actually it's something different and much more confusing that you have to like understand Blender's development history to even know what it is. The trouble is that if we want to go through this process for all of these shapes, it's going to take us at least 4 hours. And I mean, you can do the math. Do it as fast as you can, and then multiply that by the number of shapes you have. That's how long it's going to take you for every character. And that's not even the worst thing about it. Check this out. If I take the armature and the character object and press Alt-D, create a linked duplicate, you'd see that our armature is not working on the duplicate, and that our original armature works on both the original and the duplicate. That is not good. Now, why would we want to do an Alt-D duplicate instead of a linked duplicate? Well, the reason is because now we can edit our original character, and the duplicate also gets edited. If we Shift-D and duplicate, you can see that it still works, but we've just created new data. So if we edit this, the original stays the same. And now we've got like a broken link in our workflow. That's no good. Why would you want to have multiple instances of one character, you might ask? Well, imagine you're animating a crowd or a fight scene with a lot of different enemies or something. Or maybe maybe she's like looking in a magic mirror or something, and there's a version of her in the mirror that's got to be identical to her throughout the production. And we're going to change the character as we work or something. So you don't want to make a duplicate for that purpose, because the mirror object has to stay the same as the original, right? So I think I might be over-explaining this, but you can kind of see the problem. Anyhow, now we've got our working shape and we've mirrored it. It's time to talk about how we're going to do this with nodes. So I'm just going to go ahead and get rid of the shape keys drivers and start fresh. And you can see that that's what we've got here. So the first thing we're going to need to do is open a new panel by clicking and dragging in the corner, choosing a rigging nodes editor type, and making a new face rig. And I'll just go ahead and show you, this is the result of what I was making earlier. And you can see that it generates our whole face in just a moment. And each one of these node groups is a shape or a collection of shapes. So in order to install Mantis rigging nodes, you want to go to your user preferences and then choose the Get Extensions tab. Under repositories, click on the plus, add a remote repository, type in https://nodes.tools/extension. Check for updates on startup if you like, and that's all you need. Now type in Mantis, and there you go. Easy peasy. You can see in the add-ons menu that it's installed. We want to make it easy for us to generate an entire face rig in a single moment. So let's go ahead and add an armature. Our armature object is called face test. Reuse that name, and you can see it will delete our bones and create a new object that's got no bones in it. That's all right. Make a geometry object, and we're going to do the same thing here, but we want to reuse this mesh data, which is called ballerina. So let's add an existing geometry node. Just press Shift A and start typing in the name, and you'll get it. And what's this called? It's called geom face test. Paste that in there. And it doesn't look like it did anything, but now this object is in our geometry nodes graph. And in order to prove it, I'll show you. So right now, if we move our face test object, this stays in place. If we plug this inheritance relationship into it and move our face test object, now it follows the armature. Of course, we're going to want to add bones to our armature. So I've got a meta face collection here. Go ahead, make this a little bit easier to use. Turn on the names in front. And now we can see the names of different meta bones. Very nice. So let's go ahead and add a bone. Let's call it mouth corner.l. We'll use an inherit node to connect it to the armature, and that will create a bone down there. Let's use a meta rig node to select our meta face object and our mouth corner.l bone. And if we plug that in there, you can see the bone gets placed at the right location. Finally, we want to be able to control the movement of this bone, so let's unlock its location. And you can see what this does. See, if I lock the Y, then that Y gets locked. And we talked about that in previous videos. So let's go ahead and add a shape key to the mesh. We can use a morph deform node. Press Shift A, go to deformer, and then choose morph form. And we're also going to want to morph target. Plug the deformer in there, press E to generate, and if we get rid of the morph target, it won't have a problem. And you can see it didn't do anything because it doesn't have any target. So plug target into the empty slot. The target needs an object. So let's add an existing object and use our shape. This one. It's called mouth smile. Very nice. And just so that we can see the result when we run the graph, let's hide our meta shape, our meta bones, and let's set the value to 1. Press E to generate, and you can see that it gets turned on. You'll also notice that there are no shape keys being generated. That's because it is creating a geometry nodes modifier. If we look at our geometry nodes, we can see that it's doing some vector math on a whole bunch of different stuff. I want to also point out this bake node at the end, which you can use to bake animation if it starts to slow down, which is a nice feature that shape keys don't have. One of the other cool things about this is that you can put it anywhere in the deform stack, and it can operate before or after other deformers if you use this use offset checkbox. And finally, one important disadvantage is that you can't export these geometry nodes shape keys. If you want to export it, you need to click use shape key, and you'll see it will generate a shape key instead. And now you can export this with an FBX or a GLTF or whatever. That's unfortunately a limitation of Blender, and I understand that people are going to be using this in a games workflow. So I went to all of the extra effort of making it so that the geometry nodes and the shape keys solution are compatible, even though it's really kind of harder to deal with shape keys. You're welcome. Let's go ahead and set a vertex group for our smile, and you can see what that does. And now we want to go ahead and make a driver to control our morph deformer. So I'll go ahead and add a driver node, and I'll add a driver variable node. Go ahead and add an input to your driver by clicking on the button. Connect the driver variable to the driver node. For the driver variable, we need to plug the bone in to the xform1 input. And for our property, we're going to choose location. And let's plug this driver into the morph deform node and see what it does. And just as before, it's using the X location instead of the Z location, and it's not very responsive. So we want to set it to local space and see what that does. And it's a little bit better, but we want to make it so that the Z is what controls it. So notice that the location has 3 elements, X, Y, and Z. We can choose which one of these elements by setting this property index to 0, 1, or 2 respectively. And I'll show you. If we set it to 1, then we could turn the shape key on by moving it into a positive Y direction. And if we set 2, we can turn the shape key on by moving it in a positive Z direction. And just as before, in order to make it more responsive, we need to create an F curve with the proper keyframes. The F curve in the driver that it creates by default is just a 0 to 1 curve. See that? So we want to go ahead and make that curve with keyframe nodes by pressing Shift A, and in the driver menu you can add an F curve and a keyframe. For the F curve you can add and remove keyframes by pressing these buttons. Let's go ahead and plug these guys in, and nothing will change if we set the keyframe to 1, 1 like this. But let me show you what happens if we change the value of the frame of the keyframe. You can see that will make our curve skinnier or wider. And so just as before, we want to set this to 0.02, press E to generate. And now our bone is going to be more responsive. Finally, the last thing we need to do is add our limit location, and we're going to set it up just exactly the way we did before. And you can see that the benefit of rigging nodes, once you know how to do it the standard Blender way, you can find the node solution basically just by remembering what you already know. And obviously the way Blender works with the driver, the curve and the keyframes and the variable can be a little bit confusing and a little bit convoluted, but now you don't have to look all over the place to find all this stuff. It's all in one place. And you notice we haven't opened a single menu except to show what it's doing. We haven't clicked on different objects, again, except to show what it's doing for the sake of the tutorial. When you're working on the rig, you can just stay right here, which is very nice. So if we want to go ahead and repeat this work very quickly, we can create a node group. And this is where the payoff starts to happen. Obviously, we're going to need to make some connections to our node group, though. First thing we're going to do is add a new name for our bone and plug it into the meta rig. And sometimes you'll notice that it stops updating. There's a bug happening, I think, with the morph deform that causes it to stop updating correctly. And if that ever happens, you can open your outliner. The second tab in the outliner lets you pick different kinds of data you want to look at. Pick Data API, go to Node Groups, find your node group that isn't working. It's called Face Rig. Just go down here and turn on Do Live Update, and turn off Is Executing or Is Exporting if for some reason they're turned on. There's a lot of really complicated hacking that I'm having to do around Blender's Python API to make it work, and so there's still some problems. That's why I need all the help I can get to make this great. That won't be a problem in the future, but if you're watching it now, it might be a problem. I might not have fixed it by the time this video comes out. So now if we enter the node group and leave it, you can see it will update. Very good. We're going to call this mouthcorner.r, and you can see it will generate a bone on the right. Change it back to .l, generate a bone on the left. And we can choose any name from our meta face. So let's try brow middle.l. Press E, bone goes right there. You get the idea. Now, it'd be a good idea to go ahead and separate the base name and the left right. So let's add a concatenate strings node, which I'll probably rename to join strings in the future, and plug the name into the first input, and the chiral ID will be the second input. Go ahead and rename that by pressing N to open the N panel. Now we can switch the, what happened? Did I do something wrong? Where are you, bone? Oh, I did something wrong. Look, it's got a .l twice. Now we can switch the bone just by changing this .l to a .r down here. Wonderful. We also want to hook this up to our vertex group because check this out. If I move this up, on the left side it's fine, but if we change it to .r, it's not fine. So let's go ahead and have this chiral ID plug into our vertex group, and that's not going to work until we change the vertex group name to be .l and .r. And now you can see it's doing what we want. This is already pretty cool, but we can take it further. Let's go ahead and make it so that we can select the name of the shape, and we'll call that shape, and let's call this controller name. Oh, and we should call this one parent, and let's call this target and driver. Good to stay organized, right? So now we can set this to mouth smile, or we can set it to mouth brown. It might be nice to be able to control whether we can go up or down. So let's go ahead and add a connection to our keyframe. And remember, we want to have the same value in the limit location. Well, that's not going to work unless we have a way of choosing whether it's a minimum Z or a maximum Z. And there actually is a way to do this with the choose node. I'll go ahead and show this to you, although I don't actually like this workflow and I'm iffy about it, to be honest. What we can do is we can choose whether it's up or down. We can find this frame and we can see if it's greater than or equal to 0 using a float math node. And if it's greater than 0, then we plug the frame into max Z. But if it's less than 0, we plug in a 0. And then we need to do like the same thing but flipped. If it's less than 0, plug that into the minimum Z. Well, it doesn't work because I did something wrong. I might have gotten these backwards. This is kind of beyond the scope of what we're doing right now. There we go. Oh, no. If it's greater than 0, we want to use this number for the max. Otherwise, we want to use 0. If it's greater than 0, we want to use 0 for the minimum. Otherwise, we want to use this number. There we go. Now it works. So setting up a complicated choose can be kind of confusing. And I didn't try to explain it well there, because really the best thing to do is to just try a bunch of stuff and see what happens. You get a feel for it more so than you understand it. And really, more than anything, I'm just trying to show the power of nodes, right? Because now we can make a up or a down controller, but we're going to get rid of that because what I really want to do is I want to make it so that I have both up and down. So let's make another shape. We'll call the first shape up shape and the second shape down shape. We'll call this one up value, and we're going to need a down value also, which we're going to plug into the minimum Z. And we're going to go ahead and make a second driver. We can use the same variable, but we need to add a new curve because this curve is going to go down instead of up. So instead of plugging in the up value, we're going to plug the down value in. And let's go ahead and plug the target and the driver. Make sure our chiral ID is set to our vertex group. We can move that down. And let's call this up target, up driver, down target, down driver. Let's just make sure it feels nice. Mouse phone. And we'll set the down value to negative 0.02. And it's not quite working because it's not plugged in. There we go. All right. And this is where the payoff happens. So let's duplicate this. Let's plug the parent back in. Let's change the chiral ID to .l. And now we can plug our targets and our drivers in. Press E to generate. And we've got our left and our right. And if we want to, we can do the same thing with like an eyebrow control. Let's open up our meta. Let's look at our shapes. And I'll go ahead and add a brow middle, add a brow up, and a brow down. Let's plug this in there. Press E to generate. And it's going to give us a totally incorrect error message because it's not plugged into the parent. I need to figure out why that's happening. Anyways, now we've got our new shape key, and that didn't take very long. We can press Ctrl-Shift-D to duplicate this with its inputs to avoid having that error. Change the .L to a .R, plug the targets into the morph to form node, and just like that, we've got a second controller. Really great. For something that doesn't have left and right, we can just go with mouth, mouth, up, mouth, down. And she doesn't have more than one mouth because she's not like a troll or an ogre or anything. So we'll just leave the chiral ID blank, plug in the parent, plug in the up target, up driver, the down target, down driver. Press E to generate. Now we can move her mouth up and down. At this point, you'll notice that it would be nice if the mouth corners could follow the mouth. So let's go back into our node group. Let's take our bone and just plug it into a group output. And we'll call this control bone, and let's put it up at the top. Now our mouth corner nodes can take the control bone as their parent. Press E to generate, and there's some sort of a problem. And I have no idea what it is. So let's investigate here. Oh, look at that. It plugged something into the wrong spot. That's weird. Oh, it got all messed up. That is a bug that I did not know existed. You learn something new every day. Well, I'll fix that probably before I release the video, and then it won't happen to you. In the meantime, I need to reconnect these, which is irksome and vexing, but it's still faster than doing it by hand. And I might come up with a better way of doing this in the future. Now, our mouth corners are children of the mouth bone. Very nice. So there's one more thing I want to do here, and that is I want to show you a way of making the whole process of connecting these wires a little bit easier. So I'm going to delete these, and now we have just our mouth corner. Since these are a left and a right copy of the same thing, I'm going to make a group out of them with the morph deform node. And actually what we want to do is we want to chain a whole bunch of these nodes together. So I'm going to go ahead and plug something into the deformer node so that when we make the node group, it will create this connection for us. And let's go ahead and plug in the same information into each side, up shape and the down shape. We'll leave the .r and the .l as they are, and we'll keep this just the way it is. And you probably want to add an option to the use shape key, and you might want to be able to use the you want to turn the use offset thing to turned on. It should default to turning on, and I think I have set that to be the default. I'm not sure why it didn't. I'll explain what that is in a minute. Anyhow, our controller name is mouth corner, our up shape is mouth smile, our down shape is mouth round, our up value is 0.02, our down value is negative 0.02. Press E to generate, and it's the same as before, but now we can duplicate this, put it there. Let's go ahead and move the X form input below the deformer stuff. Call this parent. Again, it's doing that bug where it doesn't update, so add an input and then remove it, and it'll be fine. Do the same thing here. I'm very aware that there are these problems, but I'm spending all my time trying to make these tutorials right now so that people can actually use the software. Do it and make it work before you do it and make it good, right? Anyhow, for this next one, we're going to say brow middle, brow up, brow down. Press E to generate. Needs to have a parent. So we can duplicate that, plug the parent in. We'll call this one eyelid top, eyelid top up, eyelid top down. Press E to generate. And we've got our eyelids. It looks like we didn't have a shape called eyelid top up. Oh, it's because I spelled it wrong. But it will automatically generate a shape for you to edit and use if you type in a wrong name. I don't know for sure whether that's helpful or not. So let me know, because you can quickly create your shapes by declaring them here. It'll generate them in the tree, and you don't have to prepare them ahead of time. Maybe that's good, maybe it's not. Looks like we have another object there. Cool. So you can see that it's really easy now to just copy and paste these node groups and prepare a face rig real quickly. You'll also notice that it creates a new modifier for each one, which can be good or it can be bad. So the cool thing about the modifiers is that you can turn off a whole group of different deformations. This one controls the eyelids, this one controls the eyebrows, this one controls the mouth. But if that's the case, then I probably want to put all the mouth controls on one modifier and all the eyebrow controls on one and all the eyelid controls on one. So stacking them like this might or might not work. And it's a judgment call that you can make when you're designing this stuff for yourself. By the way, this use offset controller, if we turn off shape keys, use offset will make it so that it uses the rest shape of the object to calculate where the shape keys are. So you'll notice if we turn use offset off, as we've done, and then we move something that happens later, so the brows happen after the mouth, you can see it will move the mouth back to its original location. So that's annoying if you don't want it to happen, but when you want it to happen, it's cool because you can have a posed character. And let's say that I'll just make like a unique smile. That's ridiculous, but let's say she just got some really good news or something. I can add this in as a morph target, call it big smile. If I turn off use offset, and then generate this, and go down here, and blend her face into the big ridiculous smile from wherever it happens to be. That's a way that you can set like an entire face that you've maybe carefully crafted all at once. If that makes sense. It's kind of up to you to decide how you want to use this. One final really cool feature of all this that I haven't shown you yet is that the geometry nodes does everything like a live connection. So if we go ahead and make her smile, let's hide the meta shape, hide the meta rig. Go ahead and make her smile like this and try to edit the smile object. You can see we can change the shape of the smile, and we probably want to make her cheek puff a little bit when she smiles, right? So you can see what that does. And the really cool part about this is we can add any kind of deformer we want on here. Subdivide this a few times, wireframe, mesh deform, bind it, and oh my goodness, this is taking a while. There we go. That was annoying. And now if we deform this mesh deform cage, you can see our other object deforms also, but only when she's smiling. See that? So obviously this is a ridiculous example, but you can use this to create these complex layers of different deformations. You know, maybe one of the ways you want to do that is have one object like this for the character's face, and then have another object where it's the whole character's body is rigged, and you can like copy the deformation from one to the other. Stuff like that. I'll be adding new features to this to make that kind of workflow easier, and then I'll make examples and stuff. But at this point, I'm sure your mind is like running with all kinds of cool ideas of how you can set up your characters and how fast it's going to be once you make a reusable node group like this one or your own custom face rig. Like, I didn't even show you how to set up multiple, like a left and a right and an up and a down, the way I did in my example here. Which doesn't seem to be working. What's going on? Oh, that's because, did I rename the shapes or something? I really don't know what's going on here. This is awesome. I love it when this sort of thing happens right at the end of a tutorial recording. I have no idea what I was saying before I started to do this. But I definitely can't end the video like this. If this happens to somebody else, they're going to want to know what caused it and how to fix it. I know what I did wrong. I changed the name of the vertex group. That's why it's not working. So in my first version of this rig, I was using the left and the right names on the vertex groups. I think I'm going to leave that part in so that you can see my folly and you can make this face. That was everything I wanted to say and a lot more. Hopefully that explained things well enough and also left enough like open questions for you to know what you want to work on your own, figure out for yourself. Obviously don't mess up your left and your right vertex groups. So here's an example of that layered approach I was just talking about. You can see we have our morph-deforms for our standard shapes just like we did before. 1, 2, 3 for the mouth, the eyebrows, and the eyelids. And we also have this fourth morph-deform, which blends it with this object over here. See that? And this object has a special control for the mouth. With a single bone and a few constraints, you can make it so that that mouth follows this controller in our main rig. And now we just have a much more expressive way of controlling our character's mouth. Nice. And if you'd like to support what I'm doing here, help me to develop the software, continue fixing bugs, adding new features, and of course making these high-quality tutorials, then the best way to support me is through Gumroad with Mantis Rigging Nodes Component Pack, or these texture packs. If you purchase the component pack, you'll get this full humanoid rig that you can customize to your liking, because it's made out of nodes. And by now I hope that you have a firm grasp of how to use the nodes, because I think it's pretty intuitive. I hope you'll agree. And this latest version that I'm releasing alongside the video, which is a free update to what you're seeing here, will include a face rig example consisting of 7 components for rigging with shape keys. And it's the thing that the whole video is about. So I'm basically just posting the example that I used to demonstrate the face rig earlier on in the video. Finally, support me on Locals. Locals members will have access to our private community where we can talk about all kinds of cool art stuff. And did I mention the first 50 people who join on Locals will get access to the component pack for free? See, we have this password-protected private download page where you can download this cool stuff. But you don't have access to it because you don't have the password, because you're not a member. But you could fix that. So, like the video, share it with people, subscribe to it, whatever. I don't care. I have been Node Spaghetti. I'm gonna keep making cool stuff because I love Blender and I love making art. And I hope you do too, and I hope I can help you to do that. So, keep it classy and come back next time. See ya.